Okay, let's get back to EE1520. I want to make a quick announcement. Number one, starting from Monday, we will be taking attendance. So we will have so I will dedicate next Monday to teach you how to use a program that you will download from GitHub. And of course, you just type make after you have installed the environment. And then you will need to enter certain information to be recorded as attending a class, as I mentioned earlier. Okay, that's number one. Number two, I'll upload a bunch of things. Among those are related to our programming assignment number one. Which the second part of our class today, I will be talking about homework assignment number one. All right. And then I upload a bunch of programs here in the GitHub directory, and I upload the newest PowerPoint slide that I'll be using for today. So let me get to the PowerPoint. Okay, I hope you can see this. So this is what we talk about on Monday. I talk about JavaScript object notation, which I mentioned that this is a data description about the object. So what is an object? Essentially, everything can be modeled as an object. But in the object, there are two perspectives that we need to worry about. Wow, what did I just do? Okay, the floor is cracking up. Okay. So number one is about the data, the information that define this particular object. And the second part, which we'll talk about, is the behavioral perspective about the object. So let me give you an example. A person is an object. I'm an object. Okay, by the way, you're an object too. So I have a few property, my name, my gender, my birthday, maybe my blood pressure, and maybe my the knowledge I have about certain information. So depending on application, you can model the data about an object called object person. You can do that, no problem. But that's the data part. There's a behavioral part, which is about how I will behave when you interact with me. So I can speak whatever language. So for example, what's your name? What's your name? Chen Kai. Okay, so Chen Kai come to me. I just actually send a message to Chen Kai. Have you noticed what I'm doing? I actually trigger a program within Chen Kai to respond to an outside message. So you can see that an object has a perspective that's related to 0 and 1, which is the information, but that information is kind of static by itself. It doesn't do anything. It doesn't invoke any action. But an object, later we will see that not all of the object, but some of the object has a behavioral perspective, which it basically will respond to any kind of either a message or a function call from outside, such that you will be executing a small program within the object, like in my mind, how should I interact with Chen Kai in like 30 seconds ago? Okay, so this is important. I assume you already learned some other programming language. For example, the first semester, you learn how to do C programming. You learn how to write a C program. But there is I will call C, the language, I will call that it's a procedural language. What's a procedural language? Meaning that you kind of follow certain kind of structure and follow the control flow. For example, how do you call this? Have you seen this kind of chart? What is this? This is called flow chart. I don't know how you learn program, but a lot of the first-time programmer, we try to teach them how to draw such kind of chart called flow chart. Flow chart essentially saying that how is the control and control flow about your instruction. And this chart represent, for example, over here is an if then else. Okay, you check on the condition or part, decide to go to yes or no. So this is called flow chart. So essentially, when you do this kind of procedural programming, in your mind, you already know what problem you try to solve very carefully, very clearly, and then you try to draw a flow chart to make sure that whatever you will be doing match exactly the problem you try to solve. And sometimes this leads to another term you might have heard called algorithm. So what is an algorithm? Algorithm is a procedure or control flow. Mathematically, you can prove certain property. Okay, as a programmer, you don't need to worry about what I just said, the second part about how do you prove whether that algorithm really worked, or how do you analyze the algorithm about its computational or memory complexity. That's more advanced. But as a first-time programmer, sometimes we want to solve a problem. I mean, you probably heard about the term sorting. So sorting is a clear, well-defined question about how you can put a bunch of items and decide how to rank them from the lowest to the highest. Okay, so that is what we call a procedure programming. It's driven by what we call control flow. I mean, how your worry is what should be the next instruction I should be executing, leading to a successful result for that specific problem. Well, however, object-oriented programming, this is important. I want to make sure you understand the general paradigm. I mean, I feel it's inappropriate not learn about this and try to do C++ or Java or Python, and such that you're still using procedural programming thinking for object-oriented programming, which then you can still get things to work, but you miss the very important advantage of having object-oriented programming. So I said procedural programming is focusing on control flow or focusing on the design of an algorithm to solve a big problem. And then, however, object-oriented modeling is actually focused on how do you model the object. How should you define this object? For example, what's the data? What's the behavioral perspective? And usually we want to model the object in the target application domain. So let me give you an example. If I talk about, I model a person, but what application domain? If I want to do a person in a banking, you want to model a person object in the banking, then you probably need to worry about some of these income, some of these jobs, some of these history about financial transaction that's associated with this person, because a person's financial transaction is a property about a person. So you actually define that based on your application domain you want to look at, but you don't know what problem you want to solve, but you want to model a person for financial in general, so you can solve pretty much all the problem within financial domain. I mean, another example, I want to model a person, but in the context of medical service, medical domain, like hospital or patient or whatever about somebody's health. Then when you model a person, you want to focus on, say, this person's blood pressure, this person's medical exam result. So you are focusing on something which is about age or his physical condition or his some other property related to the health. So you can see that this is not clear about what's the only right way to model a person, but it's all about modeling. So usually, typically, I want to tell you that in the object-oriented programming, at the beginning, you say, okay, I want to build a system related to health. Then I start to say, well, when I build a health, I need a person. Okay, so I tentatively decide a person should have X and Y and Z. But later, when you really want to solve a problem in health, and you realize, oh, I'm missing one particular attribute about person I should have included. Then in object-oriented programming, it's actually very easy for you to revise. You can change your design. So it's not only model, but the model is dynamic. You can change it, you can add, you can subtract, and you can decide how you're going to change the model such that even though I'm not exactly clear what the specific problem I want to solve, but through the modeling, I kind of know that by doing this way, following this process, I can easily solve a problem in that particular domain. Okay, so this is a very different style of programming. So one is the procedure programming, maybe your first semester, you focus on, I already know the problem, then I solve it. But now you're thinking about, well, how do I model this person? And I don't expect my modeling will be perfect the first time, but I started with something and then gradually I enhance it and such that it will match my need. And by the way, I don't know why it's my application. And sometimes one application can actually share the modeling with the other. That's why we have to worry about reusability. Okay, so I'm going to give you an example about how we can do this kind of object programming modeling, and then we can actually talk about, well, how do I realize this in C++? And then we'll start to finally to talk about C++. So this is what we talked about last time. So an example, I said this is a GPS location. So I don't know if you know that this is the latitude and the longitude, okay, on Earth. So based on your latitude number and the longitude number, these two numbers together, it gives you one particular point on Earth. That is your GPS location. So this is the modeling. I want to model, okay, you can imagine the latitude and longitude, this kind of GPS location is very powerful, very useful. I mean, of course, Google Maps use that. All the autonomous drive will use that. All kind of tracking, all kind of telecommunication service involve locality about a particular device or person need to use that. So this is universally very powerful concept. And I don't know what's the problem I need to solve. I mean, I can use location to solve a lot of problems, but here, all I care is, well, how do I define an object called GPS location such that this particular concept about GPS object can be helping me to solve a lot of problems. I don't know exactly what they are at this moment. Okay, so that's the pair. I use this as an example. So first, where do you know about this? I can use JSON to represent. I can use JSON to represent. So this is a JSON because I have a two key, which is the latitude and longitude. I can just using JSON syntax, and I can have that. This is one way to define an object using JavaScript object notation. By the way, this is probably the easiest way to define object. Why is that? Because by doing this, the syntax is so simple. To defining an object, this is so simple. The second thing is it's very readable. If you, I mean, of course, it might not be readable to all of us, but once you're familiar with the concept about key value pair, when you look at a JSON, you kind of expect, okay, the key represent a particular property of the object I want to model. Okay, so in this case, I know I have a property or attribute called latitude, and I have the other attribute called longitude. Okay, this is just a representation of our object. By the way, this is very powerful. If I have time, I will show you how this simple paradigm can help a big company such as Google or Meta, Facebook, to represent a very complicated information they're processing. Just give you I forgot when I used this example. I was tracking for when the US presidential election. This was an election in 2016. 8 years ago, 8+ years ago, it was Trump versus Clinton back then. So they have their second debate. They have a second debate, which is a Fox News did the recording and has a Facebook post that's actually recording everybody's comments or reaction to the second debate. I remember that particular debate, that particular post under Fox News has 400,000 comments and about 20 million reaction by, well, obviously by probably about 20 million users. You think about you have a content, which is about a link to the debate itself. And then you have people's reaction, which is about in order of 20 million, and the comments about in order of 400,000. And the whole thing in that post is represented by one single JSON. One single JSON using this to represent that. And I was doing what I call social informatics. So I actually go to Facebook server to actually pull out the whole JSON so I can do further processing on that JSON. That particular JSON is 20 gigabytes. Just one post, which is one single JSON, of course, with a very multiple layer to represent all this 20 million information and the user, by the way, 20 million user for each of the user, we know their user ID, their name and timestamp and all such information. One single object, JSON level, 20 gigabytes. Okay, so this is, in fact, I want to tell you that this is very powerful. If you look at this, it looks really simple, but it can go easily, even 8 years ago, it's already 20 gigabytes. One JSON or one post, one discussion on the internet. So this has become, JSON become a description. You not only can model individual concept, you can model really complicated concept as expanding. So it's one way to do that. Okay, so I hope you get some basic idea. But later, what I'm going to do this class or next class, I'm actually going to start to see how I can represent the same information using C++. I want to introduce JSON first because I think JSON representing an object is much easier than C++. So this is an easier one, but this will help us to understand why we actually have to define a programming language for C++, represent exactly the same information. Okay. All right, the second part I want to say is that, well, this is just about the data. This actually tells me what's latitude, what's the longitude, but it didn't tell me what can I do with it. What's the behavioral perspective about the object? You can think about what's the object. Assuming this is a GPS, and if I turn it off, essentially this one is dead. It's a static. It cannot do anything but just with those two numbers that I remember, assuming this is object. But once I turn on, this object become an active, become a person, become an individual with a soul. Now you can interact with this object. In order for you to do that, you need to specify the behavior about behavioral perspective, which is usually to talk about in a programming cases that I need to define a set of member function which be able to represent the object to behave when they interact with other object or other program. So for example, I can say there is a one particular behavioral is distance. What's the distance? I want to say, hey, you gave me a GPS. Okay, assuming this is a GPS object, and this represents New York. This is a GPS location of New York. And now I'm saying that, well, I want to see whether this GPS location corresponding to another GPS location in Tainan, Taiwan, what's the distance between those two. By the way, to calculating the distance could be part of the behavior, which I will show you in C+ how we can do that. So I define a function called distance, and you can define any function that's actually touches the object called GPS later. So usually the behavioral is a small behavioral perspective is one or more small program that will be able to read and write the data. So when I say behavioral, you will say, hey, how do I model? This sounds very fancy. How do I model behavioral? But in computer science, it's very easy. Computer science, anything you want to do behavioral, it just means whether you can read or write to the data. You can think about that. If this object is your bank account, if you think about that, what's the behavior of your bank account? You go to the ATM machine. It's essentially you want to know how much money you have, which is the read, or you want to withdraw some money. That's right. That's modified. Or you want to deposit some money. That's also modified. Essentially, all the computational behavior can be described using read and write, or read and modify. Okay, so essentially it's information. You want to know what it is, that's read. You want to change its value, that's write. That basically enough to capture everything. So I mean, just give you another example. I know you guys are electrical engineering major. So for example, I launch a device in the sky. And I want to say, I want this particular device, I no longer want it. I want to have the device change its behavior, say self-destruct, means explode. Okay, so how do I say that? There's a switch. That switch is 0 and 1. That switch is a variable. And then I basically change the value from 0 and 1. I turn on the switch. And then basically whatever action, explode, self-destruction, or whatever behavior you want is there. So essentially, everything you want to control, everything you want to define as a behavioral is usually can be defined as a read and write about the data that's being looks like this. Okay, so anything has to be one of these two. Okay. All right, so now we're going to start to transition from this simple data-only representation, which is JSON, into a more complete object-oriented modeling or programming, which is in this semester, we'll look at C++. So I'm going to introduce the first concept called type. Okay, so sometimes we want to ask this question. Think about this question. I said, what type of object are those? What type of object? So you're given a bunch of stuff, okay? And then you want to see how do I actually describe those objects very easily? So I'm going to give you some example. You better wake up. I'm sorry, I forgot to bring chocolate again today. Maybe during the break I will retrieve it. Okay, if I have this, if you are seeing a bunch of objects looks like this, can you try to see what type of object? By the way, each of this is an object. What type of object are those? What? Fruits, right? This is essentially a bunch of fruits. So I have an object, I have a watermelon, lemon, pear, grape, cherry. What's this? This is passion fruit, 白浆果, right? This is passion fruit. Okay. Wow. In Taiwan, you guys are so lucky. You can access to not so expensive, very tasty passion fruit all the time. When I was in US, I really like to have passion fruit, but it's so hard to get. Okay. There's a few pieces of fruits I cannot get in US. So I'm so happy to come back to Taiwan to enjoy all the nice things I can. Okay, so you can see that some of you immediately represent what's the type? The type is represent how do I best describe this set of objects? Typing, that means, okay, fruits seems to be a meaningful and also is a, how do I say that? is a nice capture about the common property among those objects. That's called the type, called fruit type. Okay, so remember this. We're going to do that. This kind of typing has different. How do I say that? This kind of typing is important for us to write, to develop object program, and then the language actually provides some feature which support the typing in this. So let me actually give you another example. Oh, I want to, okay, let me use this as an example. Well, I have a bunch of objects here. What type of object we're talking about? This is called drone, okay? Drone. Okay, you have a bunch of different kinds of drone, right? So the type is drone. But on the other hand, I use the word type, it means generalization, meaning that I try to find common property about this set of objects, and I call it drone. The type is drone. But I also want to bring another word. I already say this word, generalization. What's the general common property about this set of objects? But the other word I will use against this is a specialization. Specialization means that, okay, they belong to the same common generalization, but they're also different from each other, and such that I might be able to specialize by creating what I call subtype, typing and subtype, which we will see that how this can be realized in a language called C++. For example, I might have a drone functionality. They are basically go certain height, certain distance. I might have some drone. It has a capability of doing camera, doing some kind of communication system. So I can have a general type called drone, and then I can specialize into different functionality. And as object programming, we should have the capability to do both. We can start with something very general, but then we can specialize to fit exactly what we want, okay? Okay, this is just another example. You can think about that. This is another example. So in C++, we actually look at the type. Then we say, okay, from time to time, I have to say this, the following, this statement about what I want to do is say, I want to deal with a certain type of object. Okay, I want to develop a program to deal with students. Then I have a type, which is all of you, each of the object is a student. So I want to deal with a certain type of object. In C++, we call this concept called class. So I used the term type earlier, but when we go into the C++, C++ has a specific keyword called class, which is to represent that. So we're going to introduce class. This is, okay, if you already know C, then essentially the difference between C++ and C is class. You can define class, then pretty much everything else is just associated with the concept of class, okay? So what is a class? The class is a common framework or specification to a certain type of object and their designated behavior. So meaning that this part is new. Okay, I already say, hey, it's a type of object. But the other thing is that why I put those objects in the same type or the same class, because they share a set of given behavior. For example, drone, as a type drone, I expect that this drone will be able to, under my control, to go up and go down and move to certain location. So I have some kind of command. I can trigger the drone to do the things I want drone to behave. Or if it's a student class, I expect that the student will respond positively to chocolate. I call student. You know, that's the definition of a student. The definition of student is you respond well to chocolate, okay? If you don't respond well to chocolate, you're not qualified as a student, you qualify as a professor, okay? So if you don't like chocolate, you're a professor. Next class you teach, okay? All right, so this is the idea about the class. Anybody don't like chocolate who want to teach the rest of the class? Thumbs up, okay? Okay, but by the way, I should say that I love chocolate and I love chocolate ice cream. Okay, and my wife knows I don't like anything sweet except chocolate and ice cream, those two things, especially chocolate ice cream. All right. So that's why my joke about professor don't like chocolate. Okay, so in object-oriented programming, I have a few things. I will talk about this one by one, so you don't need to remember this. Data abstraction, polymorphism, inheritance, encapsulation, those area. And I will start with a data abstraction, which is the class. I will use an example. What is a class? A class looks like this. I'm actually going to use an example. I have a class, a type of object called GPS. Okay, I'm going to show you let me see. Do I have a syntax part about a class? I have okay. So there are two things I want to introduce. My first introduction about class, I'm going to show you on the slide, then we're going to look at the program. I already uploaded the program to GitHub. So there are two perspectives about the class I want to teach you. I mean, you don't need to worry about anything more complicated at this moment, but this class, we make sure we understand the following 2 points. Number 1 point is that, well, how do I specify the class? How do I specify the type? This includes what kind of data. Data, we already have a JSON. So whatever you can use JSON to represent, I should be able to use the class to represent exactly the same. That's why JSON and the C++, they should be able to represent exactly the same kind of information because both of them are object-oriented. The second part about the class is the behavioral. I mean, I can define the behavior about the class because why the class is associated with the class. Sorry, why behavior is associated with the class because behavior is associated with object. But now I said, what is a class? The class is a certain type of object. They share the same behavioral perspective. That's why if I define a class, then essentially all the objects that's being instantiated from this class, or they are conforming to the class itself, will share the same behavior. For example, the student class, they love chocolate. That's the behavioral perspective. That's why I said all the students, they need to have that. Okay. All right, so the first part is about how do you define the class itself in C++. Essentially, what you define here is similar to what you have with how we can do with JSON. But the second perspective about the class is then how do I really create an object? So this is just a class. You can think about the class is like a specification about a particular type of object. Well, I have a plan, I have to specify, okay, what should be a student looks like, or what should be the drone looks like, or what should be the professor looks like as a type. But then I need to have a way to instantiate. I can create the object, create the real object. So by the way, there's two things. One is you have a plan, you have a spec, but then the other one is you need to create for each individual student or each individual drone as an object. So we're going to talk about class and object, this two. Now I'm going back to my computer to okay, inside, oh no, this is the other one. Okay, great. Okay, inside the GitHub directory. Why my Windows? Okay, so let me go back to the directory. Inside the directory, you see that I have a gps.h and gps.cpp. Okay, for the moment, let's not worry about gps.cpp. Let's worry about gps.h. Okay, if you click on gps.h, it's a file, has a lot of stuff. It's not too big. It's a 32 lines of code. But I want to simplify so we can focus on a few things. Ah, can you hear me? Okay, great. Now I can type and then still talk. So I'm going to use gps.h to explain. Okay, the first two lines I'm going to neglect at this moment. By the way, anyone know why I'm putting these two lines here? The meaning of this two lines? Yes, that's basically try to prevent a duplicate include file. So this basically say every single include file will be included in the compilation process exactly once. If you don't know this, just I'm going to put it here. So later you can learn this. Okay. So this is try to avoid including the same .h file more than once. Okay, so if you don't understand, don't worry, you can ask me or you can actually figure out yourself. It's not a big issue, but it's a very useful approach to include file together. Okay, and I said this part, don't worry about that. If I say don't worry, that means we haven't learned a lot of stuff. So I kind of give you a piece of code. By the way, I should actually tell you there is a piece of code I want to show it to you, which is I will provide a code which is under the directory of EE1520 Spring 2025. And this program is pretty big, has a lots of class. It already includes all the stuff we will be learning this semester. And this essentially provide a basic version of Facebook and Google search engine. So I hope in the middle of the semester, I will be able to teach you the whole thing. So you can see that using object-oriented programming, not too big, you can actually create a very complicated system yourself. So therefore, each of the file, they have multiple concepts, which you will be learning integrated already. And in this case, I said include core.h. At this moment, don't worry. You can either just comment that out saying that, hey, I don't need to include this file. That should be fine. Okay. So by the way, let me see. Make sure you understand. Okay, yeah, it's just an include file. You don't need to worry about that. And in this case, I'm actually don't worry about using namespace std as well. This is a small detail that you can specify. I'm going to get rid of this. And then I'm going to define a class. You see that? What is a class? A class, the name of the class is called GPSDD. And then it started from this line here. And the definition ends at this line. Okay, so this is, I will say, beginning to the end. By the way, when I say double slash, that means it's a comment. When it's comment, it's not being read by the compiler. Okay, that's the class. So you can see that class has a keyword class, and then have a class name. And then after this, you have a colon and a public core. Right now, I'm going to neglect. This is something we call inheritance. We haven't talked about inheritance, so I'm going to neglect it. So the way I do it is I will just Okay, so I have things looks like this. Okay, so now I simplify. And now I have a 3 session, which is called private, protected, public. Again, this 3 keyword has a special meaning to defining a C++ class. Again, I'm going to neglect it. Not going to tell you, but if you want to develop a class, you need to put these 3 things in there. Okay. And now you're familiar. I have I call it attribute. I have a 2 attribute. And this attribute, they're both the data type is double. And the name is latitude and longitude. So now you start to see the connection between the JSON object, GPS, and the C++ class object, because we're assuming what type of object is GPS object. The commonality is that they must have this 2 attribute called latitude and longitude. Okay. And the thing is, then the rest of this is, I will call it behavioral perspective. Because those 2 attributes are the data, and the other part is all behavioral. So the first 2 lines, I want to tell you, this is a C++ specific, we call it constructor. And then after this 2 lines, it's called member function. And that's it. Okay, you can see sometimes I can have a destructor, but in this class, I didn't even have a constructor. So if you look at the whole thing, the whole C++ class is essentially has a keyword class, the name of the class, and a pair of curly bracket. Inside the curly bracket, you have a 3 words, private, public, protected. Later, I will tell you, don't worry about that at this moment. And then you have what we call attribute, which is about the data perspective, which in this case is latitude and longitude. And then you have a bunch of behavioral related, and I kind of split this function into 2 sections. One is called constructor, one is called member function, regular member function. So let me first tell you what is constructor. Constructor is being called when you want to create an object. Remember I said, not only I want to define the object, I want to have a way to create an object. So in C++, the mechanism is called constructor. So I have to define a class. Whenever I call the class to create an object, it will actually invoke one of the constructor. It will invoke one of the constructor, meaning that, okay, the construction, the initialization will be supported with one of these 2 functions. And then I have the rest of the function, I will call it is called member function. This is related to some perspective about the object. So I have a few things which I'm going to, again, neglect it over here. Hold on. I'm going to neglect this 2 line starting with a bool operator. This part is a concept we're going to talk about. This is a very interesting concept in C++ called operator overloading. We're not going to talk about that today, but this 2 line I'm going to neglect. It's called operator overloading. And then the next 2 is a specific function handling the transition between C++ object and the JSON object. Not only that, these 2 both started with the word virtual. So this is another important construct in C++. It's called virtual function. And virtual function is a C++ way to support a concept called polymorphism. And at this moment, you probably don't know what do I mean polymorphism. Don't worry about that. It's a concept we will jump into much greater detail, probably after 3 or 4 weeks. Then we talk about virtual function and polymorphism. By the way, I have to say, if we look at the object-oriented, the traditional C programming, the hardest concept is a pointer. Pointer is, in my experience, the hardest concept. In C++, the hardest concept is a virtual function. Virtual function is very hard. I mean, it's you have to not only think about what the meaning of a virtual function, but how it's being implemented. It's very hard, but we will go slow. And my objective is to make sure everybody understands what virtual function is. Okay, eventually. Okay, you see, I get rid of a lot of things which we don't need at this moment. By the way, if I'm going to develop the GPS location the first time, everything left is what I need at this moment. All I need is latitude, longitude. All I need is this two function you can see is very simple. It's just say get latitude. What is it? Get latitude, get longitude? You can guess. It's just read. I want to read. Remember I said anything about the behavior you can simplify into read and modify. And the read function is over here. And the distance is essentially to calculate the distance between two places. And the constructor, you see that constructor has double. I can modify the value about the GPS location. So pretty much re-modify, that's behavioral. And then you have what? 2 attribute, longitude, latitude. You have a 2 constructor and 3 member function. That's enough for the class. Okay? Okay, any question before I'm now going to see how I can write the rest of the program to actually get an implement to a GPS class. Any question? Okay, so I have 3 minutes, so maybe I should introduce now to the GPS CPP, sorry. So there is another program in the same directory called GPS.cpp. So what I showed you earlier in the GPS.h is what we call a declaration. I just simply declare that what the class should look like. What kind of variable it should have, what kind of behavioral in terms of the function. Remember how many behavioral function I have? 2 constructor. And then I have, oh, by the way, important. The constructor, the name of the constructor is the same name of the class. The class name is the same as the constructor name. Okay, that I forgot, sorry about that. But I never tell you that how to implement the implementation about the behavior. Remember I said, what is the function? The member function is a small program. And now in the GPS.cpp, we're going to define those programs. Okay, so first is the constructor. You see those 2 are constructor. The first constructor take no argument. The second constructor take 2 argument. By the way, because I didn't include core, so to make it to work, I have to comment out this line. And I have to comment out this line. Let's just look at the constructor and then let's take a break in 1 minute. You can see that the first constructor is GPSBD, and then it takes no argument. By the way, in C++, when I define a member function or a constructor associated with a particular class, I need to give the class name. The class name GPSBD with 2 columns, and then with the name of the function, which is the constructor. So even though in the GPS.h, I only say GPSBD parentheses, but when I actually really implement this in GPS.cpp, I have to put GPSBD, the class name, in front of that. So this is basically the implementation of the first constructor. Okay, let's take a break here. Let's come back in 10 minutes.